Okay. Hi, everybody. All right, today's the big day. After today's lecture, you should be ready to start assignment 1. And I know a lot of you have been eager and you've already started assignment 1. If you've already started assignment 1, you've probably realized that it's not too long of an assignment. You can very easily get it done in a week. So after today, you'll have a week to do it. So the goal, we're going to get through the rest of basically C-strings, command line arguments, and then we'll talk about dynamic memory and then file access in C. At least the easy way to do file access in C. We'll do the hard way on Thursday. Questions or comments before we get started? Okay, so we ended, let me find where we are in the slides. I think we're here, C-string basics. Okay, so we ended last Thursday's lecture starting to talk about C-strings. So recall that the C language does not have a type for strings. The way we represent strings in C is with just an array of characters. But specifically, a C string is an array of characters where the actual string content ends in a special character called the null terminator. That's the character with ASCII value 0. ASCII value 0. And so the actual array of characters can be very, very big. And then the C string inside it, like the actual string content, can be much smaller. That's perfectly fine, so long as after the string content you have a null terminator to sort of signify the end of the C string, right? And so we've got an array of 20 characters. So this is like a 20-byte block of memory, because each character is 1 byte. And the first 5 characters are HELLO. The 6th character is a null terminator, marking the end of the C string. The remaining 14 characters are garbage. They're uninitialized. But that's perfectly okay, because there are all sorts of functions that work with C strings, and all of these functions know that C strings end in null terminators. And they know to look for that null terminator to denote the end of the C string. So all of these functions that work with C strings, it's okay if you give them a C string, a character array that has a bunch of garbage in it, so long as everything up to that garbage is valid text followed by 1 or more null terminators. Does that make sense? Okay, so this is a very silly way to create a C string. Literally create an array of characters and then populate those characters one at a time, including the null terminator at the end. This isn't really how you would create C strings in practice. This was just to demonstrate how they work. But this does work, right? You can print it like a string. It works just fine. Okay, the real ways that you would create C strings, there are sort of lots of different ways, and you would use a different way depending on the context. Here are 4 really basic ways to initialize C strings to string literals. A string literal is just some text in quotation marks, which we've seen that before. Okay, so here's 4 ways that I showed you right at the end of Thursday's lecture. These all do slightly different things. And so actually I have in a different set of slides, here it is, which we're going to go over this more later. But I've got a little diagram. This is actually Brewster's diagram that shows you different sort of segments of memory. So when you start up a program, it turns into a process that executes that program. Every process has its own big block of memory allocated to it, and that block of memory is sort of segmented into different parts. There's the code segment. That's where the actual program's code gets loaded into memory. Code takes up space. There's also this thing called the data segment. The data segment it's sort of separate from the stack and the heap. It's used to store static variables and global variables and global constants and things like that. The data segment has a read-only section. That's where constants would go, like global constants and static constants. Also literals, usually that need to get stored in memory, will go in the read-only section of the data segment. And then there's also a read-write section of the data segment. That's where global variables would go. Static variables, thread local variables, things like that. The reason that matters is that these different ways of initializing C strings create these C strings and store them at different places in memory. Some of these ways store them on the stack. Some of these methods store them in the read-only section of the data segment, and so on. And that matters because these different sections and segments of memory have different rules to them. And so, for example, if you do something like this on line 14, you create a character pointer and you initialize it to a string literal. This is perfectly valid. What this does is it creates this string literal as a C string, meaning a character array with at least 6 characters, HELLO null terminator. It creates that character array in the read-only section of the data segment in your process's memory. The read-only section of the data segment of your process's memory. It then sets up this string point, or this character pointer, string A, to point to the beginning of that character array, right? So it works similarly to my string. There's a character array, and then this variable points to the beginning of it. Works very similarly. But in this case, that character array, with at least 6 characters in it, is in the read-only section of the data segment of your process's memory. And that matters because it's read-only. It's the read-only section of the data segment. Also, the data segment is sort of fixed size. Okay, so what that means is that this pointer points to a sort of constant array of characters. It's read-only, meaning it's constant. You can't change it. I can't do something like this. This is undefined behavior, right? This is undefined behavior. String A points to an array of characters in a read-only space in memory. You can't modify it. You can't write it, okay? Your compiler will technically let you try to do this, so this won't give you a compilation error, right? Your compiler won't catch this mistake, but at runtime it will do weird stuff, undefined behavior. Oftentimes it'll say fault, but that's not guaranteed. Okay, so don't do this. String B, this is very similar to string A, and in fact it sort of does the same thing. It creates an array of at least 6 characters stored in the read-only section of the data segment of your process's memory. It sets up string B, a character pointer, to point to the beginning of it, but it's annotated as const. Very good. Now our compiler will be mad. So some of you don't know this, but the const keyword doesn't really do anything in the context of like the runtime of a program. If you have something that's written as const, or you have something that's not written as const, it makes no difference in terms of like what your program actually does at runtime. All the const keyword does is it tells your compiler to make sure that you never modify this content, right? Basically, it turns this mistake from a runtime error with undefined behavior. It turns this mistake from a runtime error with undefined behavior to a syntax error, right? So while string A's modifications would be undefined behavior, if we tried to modify string B, 0 gets J, Jello, this is not undefined behavior. This is a syntax error, right? Our compiler won't even let us do this. So GCC, C strings, there it is. Assignment of read-only location. This is a syntax error. Does that make sense? Yeah, I guess I would just recommend never do this. If you feel like you want to do something like this, just put const in front of it instead, right? By the way, constness with respect to pointers in C is a bit weird. You read them right to left. It's a weird right-left rule. You start at the identifier, you go right, then you go left. Basically, you would read this as string B is a pointer to a constant character, or a pointer to a character that is constant, which means string B, the pointer is not constant, but the data that it points to is constant, meaning the array of characters themselves, these are constant, and so you're not allowed to change the characters. You technically could change string B to point to a different location. That is okay, but you can't do this. This will give you a syntax error. Syntax error, okay? Question so far? All right. Okay, now we've got these methods. These methods of initializing C strings are sort of similar to each other, but very different from the 2 methods that we just talked about. String C creates an array of at least 6 characters. In this case, it's actually 20 characters because I explicitly specify 20. So it creates an array of 20 characters, the first 5 of which are HELLO. The 6th character is a null terminator. The remaining 14 characters are undefined, so uninitialized. But question, where are those characters in memory? Does anybody know? I'll give you a hint. It's not the read-only section of the data segment of your process's memory, because that's what this does. Very good. It goes on the stack. So this will create an array of characters on the stack. Not the heap, not the data segment, but the stack. Again, it'll be an array of 20 characters. Basically, it's exactly like this. It's exactly like this. This one line of code, line 20, does the exact same thing as these 7 lines of code. And that's why you would really never do something like this. You can do it with 1 line of code. It creates the array of 20 characters, sets the first 6 to be HELLO null terminator, and that array of characters is on the stack. The nice thing about the stack is that it's just where most regular variables go, and most regular variables can be modified, which means this C string and its contents can indeed be modified. So I could do something like this. Now string C is Jello. This is not undefined behavior. It's also not a syntax error. This is perfectly legal. You can do this. And I can prove it. We can print the string. So I can just print, let's print the string followed by a new line. So %s for a string placeholder, \n for the new line, and then we supply the pointer to the beginning of the array. That would just be string C, the array itself, semicolon. This will print Jello. Jello.
I thought string C and string A would be the same.
They are not. They're not. They're not in the sense that string A's underlying array of characters is in a special place in memory where you're not allowed to modify that data. String C is just on the stack. Like its data is on the stack, so you can modify it. They'll both compile, but this line of code will do weird stuff, undefined behavior. Actually, let's see what it does, just for fun. Segmentation fault. Yeah, not surprising. Segmentation fault. Yeah, anytime you initialize a C string directly as a character pointer, it creates the C string itself in the data segment and sets up the pointer to point to it. But anytime you initialize a C string directly as an array of characters, using like the array square bracket syntax rather than the pointer asterisk syntax, it creates it on the stack, so you can modify it. That matters. Okay. So there's that. That works just fine. Prints Jello. And then finally, line 24, very similar to line 20. It creates a string, an array of characters. That array of characters goes on the stack. The first 6 are HELLO null terminator. But the size of this string is decided by your compiler and by your computer. This string will always be exactly 20 characters wide. This string could be, it's at least 6, because it needs to be at least 6 in order to store HELLO null terminator, but it could be more than 6. In theory, your computer could make this size 120 bytes. It's up to your computer to decide how big to make it, but really it's up to your compiler. There are lots of reasons that it might decide to make it something larger than 6, maybe for like the sake of like alignment and weird things like cache coherence and spatial locality, but don't worry about it. It will be at least 6. Importantly, because this one is exactly size 20, string C is exactly size 20, if I wanted to, I could add more characters to string C up to 19 characters of text plus a null terminator at the end, right? So I can modify string C. Currently it has 5 characters of text, JELLO. I can modify it to have a 6th character of text, Jellos, JELLOS. What do I now need to make sure that I do before I print it? Add a new null terminator. Previously, it was JELLO null terminator. Now it's JELLOS. And I've just gotten rid of the null terminator at index 5 because I've replaced it with an S. So now, after the S, I need to put a new null terminator. So then I would do something like string C6 gets null terminator, ASCII value 0, or null terminator, ASCII value 0, something like that. Okay. Okay, you really only have to manually think about null terminators very explicitly like this if you're really messing with the ends of strings in ways like this. Usually you would use C functions to do a lot of this stuff, and they deal with the null terminators for you. But this is an academic example. Okay, this is fine. This now says Jellos. Jellos. I couldn't do that with string D, because my computer could decide to make string D an array of exactly 6 characters, so there's no way that I'd be able to fit that extra S at the end. I couldn't do that. But this does let me do that. Does that make sense? Okay. Is it Yeah, it can't figure it out. So imagine that I did something like this. String D5 gets S, string D6 gets null terminator. You might expect a really smart compiler to be able to look at this code and see that eventually I'm trying to access index 6 and set it to a null terminator. And you might expect a really smart compiler, when it sees that, to think to itself, maybe I should make the array at least 7 characters wide so that this line of code seems reasonable and makes sense. The problem...
Compiler's pretty silly.
Compilers are pretty dumb, and it's kind of for a good reason that they're pretty dumb. So compilers can't look ahead and see that that you're going to try to access index 6 and make it size 7. I mean, in theory, they could in this very simple case, but you can construct examples of programs where it would just be impossible. So for example, rather than on line 28 accessing index 6, what if on line 28 I called some other function, maybe via some special thing like a function pointer, to call some random arbitrary function, and I passed in string D, and inside that function it modifies the 6th index of string D. If my compiler can't like easily trace that sort of execution, like follow it and figure out what function is being called, then it can't tell which function is trying to access index 6 and of what string is trying to access index 6. So in general, control flow in C is very hard for your compiler to trace, and it's kind of just an impossible problem for it to trace it robustly. And so your compiler isn't smart enough to look ahead and see that you're going to try to use 7 characters such that it should allocate 7 characters. It's not that smart. So you shouldn't trust it to allocate this array to be at least 7 characters. You should trust it, you should trust it to allocate exactly 6 characters. It might allocate more than that, but don't trust it to do that. Just assume that it will be 6 characters. HELLO, null terminator. So this would be, what is this error called in that case?
Overflow?
Yeah, buffer overflow. Buffer overflow. Undefined behavior, as is lots of runtime errors in C.
But wouldn't the buffer overflow happen with the last line as well?
This one?
Yeah.
Not here. So this array of characters will have at least 6 bytes in it. HELLO, null terminator. This line 27, would overwrite the null terminator with an S. And so that is legal. But now what I have isn't technically a C string anymore. It's an array of characters, but it doesn't end in a null terminator. So if I then tried to treat it like a C string, such as by printing it, that would also cause weird stuff to happen. Yeah, it would probably do a buffer overread, right? So if I did this would probably result in a buffer overread. Basically, what printf does when you give it a string, it starts at the beginning of the array of characters, and it just loops through the characters, like incrementing and over in memory 1 character at a time, printing each character until it encounters the null terminator. But this string doesn't end in a null terminator because I just replaced that null terminator with an S. So it will print HELLOS, and then it will just kind of keep going, looking for a null terminator, and it will only stop when it finds a null terminator. And so this could print a whole bunch of random characters after HELLOS. What's that? Yeah, probably not. It'll probably work, but it's undefined behavior. Buffer overread. Undefined behavior. Undefined. This is also undefined behavior. And so I just want to do stuff like this. Okay. If you want to expand your string content, you should explicitly state its size and make sure that it's big enough to expand to the length that you want it to be. Okay. Questions about initializing C strings? Okay.
Question?
Yes.
Yeah, so I see the difference between the third way and the fourth way, but what is the benefit of the creating on the second way, the constant char string B?
Good question. So because it goes in the data segment, like the read-only section of the data segment, it's actually sort of your compiler's responsibility when it's like translating this program into machine code, assembly, and then assembling it into machine code. It's your compiler's responsibility to sort of organize the executable so that when you run it, the data segment is initialized. When I run this program, the data segment is initialized exactly once. And so in the special place in memory where this C string would be stored, that's initialized once when the program first starts. In contrast, the stack, like this array of characters, that would be initialized on the stack every time I run this function. And so if my program runs this function many, many times, every time the function starts, it would have to reinitialize a new stack frame with that data. In this case, it's the main function. It'll only be executed once. But if I did this inside some other repurposable function, this line of code, like its actual initialization logic for initializing the characters, would just happen once at program startup. But this line of code, its initialization logic would happen every time the function starts, which is more expensive. And so this is what you do if you just want a constant C string, usually. Okay, great question. Other questions? Okay, let's move on. That's sort of the basics of C strings, like how to create them, how to print them. We're going to circle back to more advanced C string usage in a minute. First, let's talk about user input. So we've talked about standard output. If I want to print text to the terminal, like to the console, I use printf, right? Printf, something like this. Printf stands for print format. You supply a format string and then a bunch of variables, and it prints it. Suppose I don't want to print data to the terminal, standard output. I want to read data from the terminal, supplied by the user. I want to do standard input. Okay, there are a lot of mechanisms that you can use to do this. We're going to talk about 3 of them: fgetS, getLine, and scanf. Importantly, getLine, it works for standard input, like reading a line of data from the terminal that the user types, but it also works for file input. So we're going to see this again when we talk about file access in the second half of today's lecture. This is probably what you'll use in assignment 1 to read lines of text from the CSV file, getLine. Okay, but you can also use it for standard input. It's very versatile. So let's start with fgetS, because it's sort of simpler, but it's not as nice, like it's not as robust. Okay, here's how we use fgetS. So let me look at the man page, fgetS Linux man. There's 2 arguments. There's 3 arguments. Okay. So to use fgetS, you first have to include studio.h, which we've already included, stdio, because it's what gives you access to like printf. So we've already included that. You call it. It's just part of the C standard library. It takes 3 arguments. The first argument is a pointer to the beginning of a character array in which you want to store a line of text that the user is going to type, right? And so suppose you assume that the user is going to type no more than 200 characters. You might allocate an array of size 201, big enough to store the 200 characters plus a null terminator, because ultimately it's going to store it as a C string, right? So you make it that big, 201. You would pass in the pointer to the beginning of that C string as the first argument. The second argument is the number of characters that you want to be able to read. I think it's the number of characters. I don't think it's the size of the array. Let me confirm. Yes, n-1 bytes are read. Okay, so, no, n is the size of the array. So suppose you've created this buffer of size 201. It's like 201 characters wide. It can support a C string of 200 characters of text plus 1 null terminator at the very end. So for n, you would then pass in 201, the size of that buffer. The third argument is known as a file stream. We'll talk more about file streams in the second half of today's lecture, but for now, you basically just pass in standard input as your file stream. I'll show you how to do that. So for example, maybe I want to ask the user, printf, I want to ask the user, enter your favorite sentence.
Does print G do anything, or is that just a typo?
Where did I type print G?
No, you initially typed in print G,
Oh.
and then you deleted the G.
No, it was just a typo. Okay, so I asked the user, enter your favorite sentence. I use printf to do this because I'm trying to output this to the terminal. And then I want to read their favorite sentence, whatever they type. I want to read it into a C string. First, I have to create my character array that's going to store that C string, because C strings are stored in character arrays. I want to be able to specify its size. Maybe I'm only allowing the user to enter at most 200 characters. So I'm going to create a C string called maybe favorite sentence of size 201, right? So I have to use sort of this syntax to manually create a character array so that I can specify the size, just like this, right? Also, this C string needs to be modifiable because I'm about to like basically take in whatever characters the user types and store those characters in this C string, which means I need to be able to modify the characters in the C string. So again, we have to use the array syntax. You can't use something like this pointer syntax for this purpose. Okay, so the array is size 201, so it can store a sentence of length 200 plus a null terminator at the end, right? There's my buffer. Then I call fgetS. The F usually in most of these F functions stands for file. And I think indeed it stands for file in this case as well, because you can also use fgetS for file input. Okay. File get string. That's what the S stands for. So like I said, the first argument is a pointer to the beginning of your array of characters in which you want to store the text. I've got this array of characters in which I want to store the text, so I want to pass a pointer to the beginning of it. If you just type in the name of the array, that will give you a pointer to the beginning of it. You could also do something like address of favorite sentence at index 0. This gives you the address of the first character in the array. That's also a pointer to the beginning of the array, but that's the same thing as just saying favorite sentence. I mentioned that last lecture. Okay, so there's the first argument. Second argument is the size of this array, right? So I'm going to enter 201. That's how big it is. fgetS will only read at most n minus 1 characters. So n is 201. If the user types in 500 characters, this will only read the first 200 characters, store it in the first 200 places in this array, and then initialize the 201st character to be a null terminator, right? And that's what we want. Okay, so that's why you have to specify that size, so it prevents like buffer overflows. Okay. Third argument is the file stream from which we want to read text, this line of text. I said that you can use fgetS to read from arbitrary files. You can also use it to read from standard input. At any given point in time in C, there's this special built-in called stdin. It's a file stream pointer to the standard input stream. So you can use it in place of another file stream pointer to read from standard input, just like this. There's also standard out and standard error. But in this case, we're reading, so we use standard in. Okay, and then maybe just for fun, we want to print the text back to the user. So we say printf. Really? Her favorite sentence is just make fun of them.
Should there be an extra backslash there after the S?
Yeah, because I want to print quotation marks.
Oh.
And if you want to print quotation marks, you have to escape them. I could use single quotes to make it less confusing. All right, and then we print their favorite sentence. Okay, importantly, when fgetS reads the user's input, like at most 200 characters of input, it will automatically null terminate that input. So you don't have to manually go in and like set null terminators anywhere. It will automatically set those null terminators for you. And so this, by the time we're done running this function call, favorite sentence will be a valid C string ending in a null terminator. And then this should work. C strings. Enter your favorite sentence. Eat more beef, kick less cats. Less cats. Your favorite sentence is eat more beef, kick less cats. I don't know why I put it on a new line. Yes, I do know why I didn't put it on a new line. Thanks for reminding me. Okay, so this worked in general. This worked, right? It read the user's input, stored it in our C string, printed it back to the user. There is one problem with fgetS. It's not really a problem, but it's something that it does. GetLine also does this. When it reads the user's input, it reads everything up to when they pressed enter, because standard input by default is line buffered. So it reads the entire line, everything up to the enter key. And it reads all of those characters that they typed, and it stores it in this array of characters, including the enter key itself. So when the user presses the enter key, that sort of injects like a line feed, the little \n character. It injects that line feed into the standard input stream, like into that buffer, which then gets stored inside this array, right? And so at the end of their string of content, inside this C string is a little line feed character. And so then when we print it back to the terminal, it prints your favorite sentence is eat more beef, kick less cats, line feed from when they pressed enter. That enter key got stored in the string. And then there's a question mark, exclamation point, and then there's another line feed. And so that's why it looks like this. So line feed after there, because here's where I pressed enter. And then there's another line feed here. Does that make sense? Okay, there's a way to get rid of that line feed character. You basically have to manually trim it. That was the suggestion. I'll show you how to do this in a bit. You'll need to understand certain string functions like strlen in order to get the length of the string. There are technically other ways, but that's the simplest way. Okay, so we'll deal with that later. For now, just understand it stores the line feed character in there. Okay, question so far? Yeah.
What happens if the user goes like over
It just stops. So this number that you put in the middle, the second argument, it sort of is an upper limit. So imagine that inside this function there's a little for loop that runs until either it encounters the enter key from when the user pressed enter, the line feed, or until it has run this many times minus 1. So 200 times. That's upper bound.
Follow up, unrelated, but when you're doing the backslash, that would count as one character.
Yep. On StarNix systems, it counts as one character. Because on StarNix systems, an enter key is just a line feed, which is one character. On some systems, like DOS inherited systems like Windows, an enter key might be 2 characters. It might be a carriage return line feed.
What about the %s? Is that also one?
%s.
Yeah. So like insert it, or I guess you wouldn't really.
Right. So %s isn't really, I mean, it's kind of 2 characters, a % and an s, right? But it's really just a format specifier. It's just interpreted in a special way by printf. Yeah.
Because enter is included, really the percent can only be 199.
Yes, very good. Yeah, the sentence could really only be 199 characters because the line feed at the end would be the 200th character. Yeah. Or technically it could be, you could enter 200 characters, the line feed would just remain in the buffer.
Oh, so it just trims it.
Yeah, it sort of trims it for you. If the user types in more than 200 characters here, it will read the first 200, null terminate it, and then whatever remaining characters there were in the buffer that the user typed in, they stay in the buffer. So then next time you call fgetS, it will start reading those characters. Yeah. Okay, other questions?
Oh, you have to grab that, so you have to clear the buffer.
Yeah, you would have to clear it. There are ways to clear it. But there are better ways to do user input, such as getLine, which is next. Okay, let's do getLine. Again, I have to remind myself, Linux man 3. What's the interface for getLine? I think it takes 2 arguments. No, it takes 3 again. Okay. getLine is a little weirder. It's harder to call. Its interface is more complicated, but it does a lot of stuff for you that makes it more robust than fgetS. And so this is actually probably what I would recommend using instead of fgetS in most cases. I would recommend getLine. Although I think maybe it's technically part of the POSIX Unix standard instead of like the C standard, and so it might not be available to you if you're like trying to compile for Windows. But it's definitely available on StarNix systems, like on the OS1 server. It's called getLine. So getLine, also provided by stdio.h, is an alternative to fgetS. It's used to read a line of text from the user, but you don't have to specify like an upper bound on the number of characters to read. You also don't need to pre-allocate an array of characters in which to store the user's line of text. Instead, this function is capable of reading any number of characters that the user types, and it dynamically allocates an array of characters that's big enough to store all of those characters of text. It's called a dynamic array, which we'll talk about pretty soon, but it uses dynamic memory under the hood, which does mean you have to free its dynamic memory later, which I'll show you how to do in a bit. Okay, it also takes 3 arguments. The third argument is the same. It's the file stream pointer from which you want to read a line of text. So that's going to be standard in, stdin. But the first two arguments are a little bit different. Notice the first argument is of type char star star. In the case of fgetS, the first argument was just of type char star. It was a pointer to the first character in an array of characters in which to store the text. This time with getLine, it's a char star star. It's a pointer to a character pointer that will eventually, once the function is done, will eventually point to an array of characters in which the user's text is stored. The character pointer itself also has to be initialized to null. So for example, here's how you would use getLine to read a line of text from the user. Let's just like sort of rewrite our fgetS example using getLine instead. You would start by creating a character pointer, char star. Call it whatever you want, maybe favorite sentence again, same as before. You initialize it to null. This is usually what you're going to do, initialize it to null. Recall that null is not a built-in in C. You technically have to include certain header files in order to get access to this constant called null. If you include standard io.h, that does give you access to null, at least on most systems. In the worst case, if you still don't have access to this keyword called null, this constant called null, include standard def.h or standard lib.h. Pretty much any of these will work.
Can you just force define null?
You could define it yourself, but I don't know. Doesn't really matter. Okay, so we've created our character pointer. It's currently null, meaning currently this character pointer does not point to any particular array of characters at all. It just stores the memory address 0. The idea is that when I call getLine in a minute, it will dynamically allocate an array of characters in which to store the user's input, and it will modify our pointer to point to that array of characters, right? So I'm going to call getLine. The first argument that I supply is this pointer, but I pass it by pointer. Why do I pass favorite sentence by pointer? Why do I pass its address to getLine rather than its value to getLine? Yes.
Function needs a double pointer.
Yeah, why does the function need a double pointer, like philosophically?
Because you need
Point
to
to
point
a
to the
string.
pointer that you're going to use.
Okay, so this function getLine, it's going to read a bunch of text from the user. It's going to count how many characters the user typed in. It's going to create an array of that size or bigger, an array big enough to store all of those characters of text that the user types in. And it's going to update our pointer to point to that array of characters. It dynamically allocates this array, and it updates our pointer to point to that array. In order for getLine to be able to update our pointer, when we pass our pointer to getLine, we have to pass it by pointer, because functions can't modify external variables unless you pass them by pointer, right? Because parameters are copies of arguments and all of that. And so if you want a function to be able to modify its argument through the parameter, the argument has to be passed by pointer. We need getLine to be able to modify this pointer to point to a dynamically allocated array of characters, so we have to pass it by pointer. That's a lot of layers of confusion, but this is how you do it, right? You also have to make sure that you initially set it up to be null, your actual pointer itself. Otherwise, it will do something else. You can read the interface if you want to know what it does in that case. But I would just set it to null. Okay, that's the first argument. A pointer to our character pointer, which when this function is done, will be updated to point to an array of characters storing the user's text. Okay. The second argument is a...
This question.
Yep, go ahead.
This might be a dumb question, but is what is by reference and by pointer the same thing? Or
By reference doesn't exist in C, because references don't exist in C. References exist in C++. So,
okay.
yeah. Okay. Good. So, the second argument. Second argument is a pointer to, it's an integer, right? It's a size t. Okay, so maybe you remember in the beginning of our C review lecture that I said there are a lot of types in C. There's int, there's char, there's double, there's float. But I also said there are some weird ones that are sort of aliases for other types. I told you about one called size t. Size t is a type. It's used to represent sizes of things, such as sizes of arrays and sizes of variables and things like that. It's usually sort of equivalent to like an unsigned long int or unsigned long int or something like that. But if you intend to represent sizes of things, you should technically use the size t type. The second argument to getLine is a pointer to a size t variable. So here's what I'm going to do. I'm going to create a size t variable, n. I'm going to initialize it to 0, although I don't think you technically have to do that. And then I pass in n by pointer. When this function is done, this variable will have been modified to point to the array of characters containing the user's line of text. This variable will have been modified to represent or to contain the size of that array of characters that was allocated, I think. Let me confirm.
That's the return.
Or is that the return value? I said the interface was complicated.
The return value is the
No, that was right. So the return value is the number of characters read, including the delimiter character, but not the null terminator, and will be updated to contain the size of the buffer. And so this will be updated to point to an array of characters. This will be updated to store the size of that array of characters. The return value will be the length of the C string, which could be smaller than n.
Oh,
Yeah,
it's the
yeah, yeah.
thing where
Yes, this interface is very...
processor overcompensates.
Yes, so this interface is very complicated, but bear with me. Okay, the third argument is the file pointer stream from which you want to read a line of text, standard in. This is how you would use getLine to read a line of text from the user. These 3 lines of code, or something like this. When this is done, this will point to a C string containing the user's line of text. This will store the size of the character array, like in bytes, that pointer now points to. It does technically have a return value. It returns the length of the C string. So suppose the user types 5 characters, so like HELLO or something like that. The underlying dynamic array of characters that this function allocates will be at least size 6, big enough to store HELLO null terminated. So it will be at least size 6. So n will be at least 6. The size of that array is at least 6. It will then return exactly 5, HELLO, the size of the C string. But everything I just said was off by 1 because also the new line, like the line feed, gets included.
The return to quickly remove the new line.
You could do that, right? You could do that. But we'll just use strlen later because I'll talk about strlen anyways. I know, but we'll talk about strlen. It makes things easier. Okay, so this is how you do it. This does the same thing as this. However, there's one very important difference. I know this interface is very complicated, but notice nowhere in these 3 lines of code did I need to hard code a size of a character array. Nowhere did I need to say, I want to create a character array of 201 characters and then read at most 200 characters from the user. I didn't need to say anything like that. This interface, getLine, is capable of reading any number of characters the user might type. It's very versatile, very powerful. It uses dynamic memory though, which means you have to free the data that it allocates, which I'll show you how to do later. But it works.
Think of a situation where it's not ideal.
I would basically always do this. I would use getLine. Yeah, it's much more robust than FGetS.
You're working with limited memory and they just put in way too much.
Yes, that's true, but you can pre-allocate the array for getLine as well. It is possible. Okay, here we go. Still works. Questions about getLine? Okay, for assignment 1, you're going to do this to read a line from the CSV file. You're just going to replace standard in with the file pointer, like the file stream pointer to that file, which I'll show you how to open soon. Okay, there's one more way to read inputs from the user. It's called scanf. Scanf is pretty nice. It stands for scan formatted in the same way that printf stands for print formatted. The purpose of scanf is if you want to read formatted inputs from the user in sort of a similar style to the way that you would print formatted outputs to the user. So for example, suppose I want the user to enter an integer, right? Printf, enter your age, something like that, okay? I then want to read the user's input, whatever number they type. Let's assume that the user is going to be nice to us, and they do indeed type in an integer. I want to read their input, that number, and I want to store it in an int variable, user age. The problem with getLine and FGetS is that they don't work with integer variables. All they're capable of doing is reading an entire line of text and storing it in a character array as a C string. That's all that getLine and FGetS are useful for. If you want to read the user's input and store it in an integer or a double or some other weird like formatted type like this, an easy way to do this would be to use scanf. Scanf does not have very robust error handling capabilities. It has some. But in general, you would usually only use scanf if you really trust the user. If you trust that the user will indeed type in an integer. Because if the user doesn't type in an integer, then this won't work. Okay? So I call scanf. This scanf only takes 2 arguments because scanf doesn't need to have a file stream because scanf always reads from standard input. So I don't need to specify standard in. There are just 2 arguments to scanf. The first is a format string, similar to printf's format string. So for example, if I expect the user to type in an integer, recall that %d is the format specifier for integers. It stands for decimal. It doesn't stand for double. %lf is the format specifier for doubles. %d is the format specifier for int, right? So the first argument is the format string. You could have multiple format specifiers in here. If I expect the user to type in an integer followed by a string, like a one word string, I could do something like this. I could have 2 arguments here. Okay, but I'll just do 1, %d. The remaining arguments, there's usually going to be at least 1. There technically could be more. The remaining arguments, just as is the case with printf, is a sequence of variables in which you want to sort of store the corresponding placeholder inputs. So in this case, our format string has 1 placeholder, %d. That's going to be the integer entered by the user. That's what it's a placeholder for. I want to store that integer inside user age. So the second argument is going to be user age, except this function needs to be able to modify user age to store the user's input. So how do I pass in this argument? I pass it in by pointer. Okay, very good. Anytime you want a function to be able to modify something, you pass it in by pointer, right? You pass its address. You could also just look up scanf, Linux man 3. Look up the man pages for scanf, and it will tell you, well, you have to read it carefully, but it will tell you that the remaining arguments are pointers. They have to be passed by pointer.
If
Okay,
you just want to read whatever the users get.
like as a string?
Yeah.
Then you would use getLine or fgetS. Yeah, different function for that. Okay, so something like that. And then I say printf, and then maybe I flame the user again. Really? Oh, no, it's their age. All right, your age is, make fun of how old they are. Okay, %d user age, something like that.
I don't know if you need quotes.
I don't know. Enter your favorite sentence. Enter your age, 25. Really, your age is 25? Of course, scanf does not read like line feeds. I mean, it recognizes the line feeds and it sort of ignores them, but it doesn't like read the line feed character from when the user types enter and store it in the age, of course, because the age is an integer and it's not capable of storing line feed characters.
Does it do that if you're reading it?
I think it does if you're reading a string. If the format specifier were %s, you're asking the user for like a word, and then you stored their word inside inside the string, some string variable, like a character array or something like that, then yes, I think it would store the line feed character if they entered 1 word. Don't quote me on that. Okay, questions about scanf? Okay, yeah.
Does scanf like validate if with like who can call if you enter a floating point?
So it does do a little bit of validation. It does have a return value. It returns an integer, which tells you the number of tokens that it was able to successfully read. And so if the user types in a token that doesn't match the desired type, it will fail to read that token. And then the return value in this case would be 0 instead of 1, because it failed to read that 1 token. But its error handling is not very robust. I know there are a lot of weird edge cases that kind of trick it. I think if you ask the user for an integer, for like their age, and the user types 3.14, I think it would just read the 3. Well, let me see. Maybe I'm wrong. Let me try not to lie to you. Enter your age, 3.14. Yes, it does read the 3. So it succeeds to read the 3. It would even return 1 for the number of tokens successfully read. And so scanf's error handling capabilities are not very robust. And that's why if you don't trust the user, usually you wouldn't use scanf. If you don't trust the user, what you'd usually do is read their entire input in 1 line, store it in a C string, maybe with getLine, and then you programmatically would go back and validate all of their inputs in that C string, parse them, and so on. And there are ways to do that. We'll talk about how to do it soon. Okay. Let's move on to command line arguments.
Question?
Yeah.
Yeah, so you said that we pass in as pointer for changing the scanf and getLine, but why the fgetS not have to pass as a pointer? I think you talked about it, but I forgot.
It sort of does. So fgetS doesn't need to be able to modify like a pointer to an array. It needs to be able to modify the array itself, so like the characters within the array. In C, if you have an array of anything, let's say an array of characters, right? An array of 201 characters. If you write out the name of that array, favorite sentence, this expression will dissolve to a pointer that points to the beginning of that array. And so technically I am passing a pointer here. That's to say this is equivalent to the address of the first character in favorite sentence. right? I just don't technically need to write out all of that syntax because it's implied. Yeah. It's just weird C syntax logic. Yeah. Okay. Other questions? Okay. Let's do command line arguments. And then C string, functions, strtoc, and then we'll take a break. Okay. Good. Command line arguments. So all of the main functions we've created so far have had no parameters. I'm going to create a new file for this. Command line args.c. Okay. All of the programs we've written have had main functions, and these main functions have never had any parameters. As it turns out, you can put parameters in a main function. Specifically, you can create these two parameters called argc and argv. The first one is argc. It's usually an integer, although I think some people do like size t. That would make sense. And then the second one is called, usually we call it argv. You can technically name these whatever you want, but convention is to call the first one argc and the second one argv. The second one is, there's a couple of ways to express it. It could be a char star star argv, or it could be a char star argv array. These are the ways to do this. Either way it will work, because arrays kind of behave like pointers as function parameters. Yeah. I would make it constant. That's a good idea. You don't have to, but I think technically it's guaranteed to be like on the stack or some writable place in memory. So it doesn't have to be constant. But it's usually convention to make it constant. And if you want to modify it, copy it elsewhere. Yeah. Okay. So this first guy, argc, it stands for argument count. The second guy, argv, stands for argument values. In the shell, when we're executing a program, such as, let's say, mkdir. mkdir is really not special. It's just a program that lives in a special place on the engineering servers. When you execute mkdir, you'll supply an argument to it. You wouldn't just type mkdir and press enter. You would say mkdir, and then you would give it an additional input, such as my directory. And then you'd press enter. And that creates a directory called my directory. When you're running the program, mkdir, this thing right here, my directory, it's called a command line argument. It's an argument to the program that you specify at the command line, meaning in the shell when you're executing the program. As it turns out, you can also run C programs, like programs that were written in C and then compiled, and you can supply command line arguments to them as well. That's fully possible. In your C program, not that one, in your C program, if your main function has these parameters, these parameters are basically used for receiving those command line arguments. Okay? argc stands for argument count. It represents the number of command line arguments that were passed to the program, technically +1, which we'll get to that. argv is an array of character pointers, each of which points to the beginning of a C string. Suppose the user types in, when they run this program, suppose they type in ./a.out, because suppose that's the name of the program, and then they type in hello space world. If they run your program like this, argc will be 3, 1 for a.out, 2 for hello, 3 for world. So there are 3 sort of arguments here. The first one in some sense isn't an argument, but you can think of it like one. So argc will be 3. argv will be an array of 3 character pointers, sort of, more or less. The first of which points to this character, the second of which points to this character, and the third of which points to this character. So each character pointer in argv will point to the beginning, technically, of a C string containing the corresponding command line argument, right? And so, for example, maybe I want to write a C program that maybe in a for loop. For. Maybe I want to iterate through all of the command line arguments given to the program and just print them. This is a very silly example. Maybe I want to do something like that. So I say I get 0. There are a total of this many arguments, argc. So I want my loop to run that many times, ++i. And then maybe I just want to print the ith command line argument. So I say printf. Each command line argument is stored as a C string, right? So I'm going to print a string and then a new line feed character, new line. And then which C string do I want to print? I want to print the one that is pointed to by the ith character pointer in argv. So argv is an array of character pointers, each of which points to a different C string, and each one of those C strings stores a different command line argument. They are stored in order. So argv at index 0 will be a pointer to a.out, or a C string containing a.out. Argv at index 1 will be a pointer to a C string containing hello, and so on. Okay, something like that. I do need to include studio.h to printf. So if I just type a.out, it just says a.out, the sort of the only command line argument. If I say a.out hello world, and it says a.out hello world, right? Here's a fun thing. This doesn't really matter that much right now, but it might matter when we talk about like shell scripting next week. If in the shell, if you surround a string in quotation marks, usually it will then treat that entire string as one argument. So if you use it as a command line argument, hello world will now be treated as a single command line argument rather than being treated as two separate command line arguments. Basically, the space is, the space is somewhere within quotation marks, it's not treated as a delimiter or a separator between arguments. It's just treated as part of the one argument. So now, hello world is printed on one line instead of two. Notice the quotation marks are discarded though. Just hello world, no quotation marks. Okay. That's pretty much it for command line arguments. Are there any questions about command line arguments? Yeah.
So space is the only character by which those arguments are delimited?
Yes. So, well, it might be any white space. What if I said hello tab world? Oh, right. I can't do tabs easily. There's a tab. Yeah, so I think any white space will technically delimit arguments, except the enter key, because that will just run the program. Yeah. Okay, other questions? Okay. So I think the last thing I'll tell you about command line arguments is that you'll usually make this second argument, argv, you'll usually make it a constant, which means that you can't modify the text contained within the arguments themselves, which that seems fine. Like, why would you want to do that anyways? In theory, you can imagine weird cases of like text processing where you might want to like sort of modify the arguments to do weird, like transform them in some way before your program otherwise processes them. If you wanted to do that, if you wanted to take that text stored in these arguments and modify them, you would usually copy their text into a different C string first. And so there are various ways to do that, one of which is stir copy. And that's, I think, maybe even the next thing I'll show you. C strings, let's say C string functions.c. Okay. Yeah, we'll get to stir talk. Okay, this is the last part of our C review lectures. Then we'll take a short break. Then we'll do dynamic memory file access. Okay. When you have a C string in C, it's really just an array of characters that ends in a null terminator. And so you can imagine that working with C strings might be really complicated. In C++, if you had a string object, or in Python, if you had a string object, or in Java, if you had a string object, and you wanted to like get the length of that string, there's probably like a member function that will do that for you. MyString.length, or something like that. C strings are not fancy objects with member functions. They're just arrays of characters that end in null terminators. If you wanted to get the length of a C string, like you wanted to figure out how many characters of actual text are in this C string, how would you do that? Ignoring, if you know about strlen, ignore strlen. Like if you wanted to manually, programmatically write a function that determined the length of a C string, how would you do it? Yeah.
You would loop through every character in the array, counting them until you got to the null terminator.
Exactly. So every C string is an array of characters that ends in a null terminator. So if you wanted to figure out the length of a C string, how much text is in it, you might have like a while loop or something like that. That loops through each character in this array one by one until it encounters a null terminator, and it just counts as it goes. Like you have a counter that increments in every iteration of the loop body. And then by the end of the loop, whatever value that counter has inside it would be the length of your C string, maybe plus or minus 1, right? Okay. That's a complicated process just to get the length of a string, right? In C++ or Java or Python, if you want the length of your string, you don't need to write a loop. You just use a string member function. Well, as it turns out in C, there are functions that are part of the C standard library that operate on C strings that accomplish basic goals about C strings for you. They're not member functions, so I can't say something like myString.length. You can't do this in C, because in C, C strings are just arrays, and arrays don't have dot operators. They don't have member functions. Even structures don't have member functions. What was that? There are no methods at all in C. What you do instead is you include this library called, is it string.h? Strings.h? It's one or the other. GCC C string functions. Yes, I think it's string.h. Okay, so we include string.h. It gives you access to a bunch of global functions that you can call, where you pass in your C string, and they manipulate that C string or return data about that C string and so on. So for example, suppose I've got a C string. My string gets hello. Recall that with this initialization syntax, it'll go in a read-only section of the data segment, my process's memory, so I can't modify its characters, but maybe that's okay for now. Suppose I wanted to determine the length of this C string. I know that it's 5. Like I could just count the characters, 1, 2, 3, 4, 5, plus a null terminator at the end. But suppose I wanted to programmatically, with some simple function, without needing to use a loop, figure out the length of this C string. There's a function that does this. It returns, I think it returns a size t value, right? So I might say size t length gets. The function is called strlen, S-T-R-L-E-N. It's given to you by string.h. You give it a pointer to the beginning of a C string. So my string is a pointer to the beginning of an array of characters containing a C string, and it returns the number of characters of text in that C string, not including the null terminator. So this will return 5, H-E-L-L-O. Printf, %d\n length. This should print 5. If I include studio.h. Include studio.h. 5. Okay. Strlen is one of many C string functions in C. I'm not going to go through all of them because there's a whole lot of them. I'm probably not even going to go through all of them that I pointed out in the lecture notes. But here's a couple of them that you might find really helpful for assignment 1. Strlen might be really, really helpful for assignment 1. For example, when you read a line of text from the user or from a file using getLine or fgetS, as we just went over. Where did I do this? Was it in main.c? No. Was it in, I think I might have put it in cstrings.c. Okay, here it is. When we read a line of text using getLine, it read all of the characters that the user typed up to when they pressed enter, including the enter character, like the line feed at the end. Suppose you want to get rid of that line feed character. Here's how you would do it. You would use strlen, or at least this is one way. You would use strlen to figure out how long is this C string? How many characters are in it? Suppose there are 20 characters of text in it. That 20, as returned by strlen, will include the line feed character. You would then grab the 20th character, the line feed character, and you would just replace it with a null terminator. The C string's text would then be 19 characters. The 20th character would be a null terminator, so it would then be a C string containing 19 characters of text without a null terminator at the end. So you could do something like this. Size t length get strlen favorite sentence, and then you could say favorite sentence at index length -1, because indices are off by 1. I want to get the last character of text. That would be the line feed, and I would replace it with a null terminator, right? This would trim the line feed, the \n, replaced with \0. Does that make sense? You might do this in assignment 1. There are ways of completing assignment 1 without doing this, though, so you technically might not need to do this. Okay. Good. Let's go back to C string functions. What else? Suppose you have 2 C strings and you want to compare them to each other. Maybe you've got like 2 movie titles and you wanted to compare them for some reason. Maybe with an if statement, if 2 C strings are equal. Maybe I've got my string is hello, and then const char my string 2 gets jello, something like that. If I wanted to compare these 2 C strings, I can't just use an equality operator. If my string equals my string 2. Why can't I do this?
Carrying the point.
Very good. MyString is a character pointer. MyString2 is a character pointer. This checks if they point to the same address in memory. This doesn't check if they contain the same text content. But usually when you're comparing C strings, you want to compare their text content, right? To compare two C strings' text content, again, you could use a for loop. It looks at each character one at a time to make sure all the characters match, or you could use strcmp, strcmp. You give it two C strings, technically the pointers to two character arrays that contain C strings, MyString, MyString2. It will return 0 if they are equal. That might be weird because 0 sort of means false. So it basically returns false if they're the same. And it returns a non-zero value if they're different. Basically, that's the way that you can think of it. Often, it can also be used to like check if one comes before the other alphabetically based on the sign of the output. But in the simplest cases, you're just going to check if they're exactly equal compared to 0. Note that it is case sensitive. So if MyString2 is hello with a lowercase h, and MyString is hello with a capital H, strcmp will not return 0 because those are not the same. A lot of negatives, but that's how it works. Does that make sense? There are functions that sort of convert strings to lowercase, but they're complicated because you have to create new string buffers to store those and so on. But you can look them up if you want to. Printf, they're the same. In this case, this will not be printed because they are not the same. Uppercase, lowercase. Now they're the same. Now it would print they're the same. Does that make sense? Questions about strcmp? Okay. There's also strcat. I don't think I need to tell you about strcat because I don't think you're going to need it for assignment 1. It's in the lecture notes if you want to know how it works. It is used to concatenate two C strings together. It's a bit weird. You give it two C strings, it concatenates them together, and then it stores the concatenated result in the first C string's character array, which means that the first C string's character array needs to be much, much bigger than the C string contained within it, so that it's also big enough to store the second C string once they concatenate together, right? So it's a little weird. It's not a very good interface, but that's how it works. Either way, you shouldn't need to know it for assignment 1, so I'll skip it. What else? I've got a bunch of them in the slides. I'll skip strcat. I've done strlen. Strcopy. Strcopy is pretty nice. Suppose you want to create a copy of a C string. For example, suppose I want to take my string and all of its text and copy it into a new C string. I can't simply do this. MyString3 gets MyString. Why can't I do this? Okay, very good. This is copying pointers. Once again, MyString is a character pointer. MyString3 is a character pointer. This just takes the address that's stored within MyString and copies it into a new pointer called MyString3. This is just copying addresses. We still, in this case, just have one string with two pointers that point to it. Suppose that's not what I want. Suppose I want to create a new C string, and I just want them to have the same text inside them. Okay, so what I would do, probably, is create MyString3 with like the array syntax. I would have to make it big enough, at least, to store the text that I want it to store. In this case, I want it to be a copy of my string. So it needs to be at least 6 characters wide, HELLO, null terminator. I've made it 10, just has to be at least 6, right? And then to actually copy the text from my string into MyString3, you could again use a loop, copying one character at a time, or you can use this thing called strcopy. You give it 2 arguments, a pointer to the C string in which you want to store the copy. We call this the destination, MyString3, and then a pointer to the C string from which you want to copy text. I want to copy the text from my string into MyString3, right? Importantly, if MyString3 is not big enough to store all of this text, plus a null terminator, this will give you a buffer overflow and cause undefined behavior. Okay, questions about strcopy? You can technically do this. Strlen, MyString, +1, the length of the text +1 for null terminator. These are called variable length arrays. You can do this in C. It's not advised. If you want to do like variable length arrays, you should usually dynamically allocate them, but you technically can do this. Okay, let's just do that though. Okay. I think all that's left to tell you about is Sturtok. So unfortunately, we have to talk about Sturtok. Before we talk about Sturtok, because Sturtok sucks, here's another Unix beard comparison, round 3. This is Gandalf, and this is Richard Stallman. Just kidding. It's the other way around. Yeah, this is the GNU guy, Richard Stallman. He created all the GNU utilities. He pioneered copyleft. That's like the idea of like the GPL or GPL v3 now, but the GPL license, which basically means you can use my source code, but only if you make yours open source as well. There's another Dennis Ritchie. There's another Ken Thompson. Who did I say this guy was? Richard Stallman. That is who he is. Okay, let's learn about Sturtok. Sturtok sucks, but it's often the only tool you have in your arsenal for what it does. Sturtok. Sturtok stands for string tokenization. It's used to take a string that has a bunch of parts in it, separated by some characters. So maybe you've got a string, let's say const char row. Maybe it's a row from a CSV file, for example, and maybe it contains, I don't know, maybe the title of a movie, Iron Man 3, and then maybe a comma, and then maybe it contains the year in which the movie was released, or something like that. So you have a C string that contains something like that. Actually, I can't allocate it like this for reasons I will discuss. I have to allocate it like this. It has to be modifiable. So I use the array syntax. Okay. Suppose I want to take this C string and I want to extract from it this part. So I want to extract the smaller C string containing the text Iron Man 3, everything up to but not including the first comma. And then I want to extract the 2004. That is called tokenization. Each part is referred to as a token. In this case, they're separated by commas, though Sturtok can handle any kind of delimiter, such as commas, but it can also handle other delimiters. Here's how Sturtok works. It's very weird. Even though it extracts parts of a C string, it doesn't create new C strings in the process. Instead, it modifies the original C string. You'll see what I mean by that in a minute, but here's how we use it. You call Sturtok, you pass in 2 arguments. The first time you call Sturtok, the first argument is a pointer to the C string that you want to tokenize, in this case, row. I want to tokenize this C string, so I pass it in as our first argument. That'll be different next time we call it, because Sturtok sucks, but this is how you call it the first time. The second argument is a C string containing delimiters. In this case, there's only one possible delimiter. It's a comma, meaning the characters that separate tokens, right? Sturtok does not support multi-character delimiters. So for example, if there was a double comma between every column in your CSV file for some bizarre reason, passing in 2 commas does not sort of represent that. What it represents is that either of these characters are possible delimiters. So you probably wouldn't do comma, comma. But for example, comma slash, this would mean as we tokenize this string, commas will be treated as delimiters between tokens. Slashes will also be treated as delimiters between tokens. So I could do this, or I could do this, and they would have the same result.
I've never looked into this before, but I have a prediction. It'll just replace all the delimiters with no.
Yes, that's exactly what it does. Okay.
And then give you back the current pointer.
Yes. Okay. So it returns a pointer to a C string containing in this case, it's going to contain the first token. The first time you call Sturtok, it returns a pointer to a C string containing the first token. So I'm going to call it first token. Actually, maybe I'll call it movie title, because I know that the first token is the movie title. After this, movie title will point to a C string containing Iron Man 3, that text, right? So if I were to printf the movie title, this would print Iron Man 3, okay? Now, I want to extract the second token, the year in which the movie was released, 2004. Okay, I call Sturtok again. It will return the result as a C string, so maybe movie year gets Sturtok. This time, the first argument is null. As bizarre as it seems, this is how you use Sturtok. It's null. The second argument, and again, is the string containing all the delimiters. In this case, just a comma, right? You might be wondering how strtoc is capable of extracting the second token from row, given that I don't actually pass it row as an input. I pass it null as an input. The reason is that strtoc keeps track of like a static state. Every time you call strtoc, it basically remembers what C string it was tokenizing the last time you called it. And it also keeps track of where it was in the tokenization process. So when you call it the second time and the third time and on, you pass in null, which is just a special little indicator to the function that tells it, keep tokenizing from where you left off. Last time we grabbed the first token. This time I want to grab the second token, and then the third token, and then the fourth token. If you were to pass in row again, it would start over from the beginning. But also it wouldn't really work right for complicated reasons. Okay.
I thought strtoc had 3 arguments, not 2.
I think it was just 2. strtoc, Linux, man, 3. Here's our man pages.
You have to get the length of the previous token and then add 1 to it and then do it.
Yeah, strtoc R has 3 parameters, but not strtoc. Okay. This C string will contain the movie year. Notice it's stored as a C string, not an int. strtoc always returns C strings. If you wanted to convert this to an int, there are ways of doing that.
Use stir.
You can use this thing called stir to L. You could also use this thing called A to I. For the sake of time, I'll skip over this. They're very simple. You just pass it a C string and it returns an integer, basically. So stir to L on the movie year, you pass it something like 2004 or the movie year, and it returns the integer 2004. That's how you'd use that. You might do that in the assignment. This thing would also work in that case. Okay, good. That's strtoc in a nutshell. One weird thing about strtoc is that it modifies the original string that's being tokenized as it goes. In fact, if I were to print row, the original C string, maybe %s\n row, if I were to print row at the end of all of this tokenization, does anybody know what it would print? I think you know. Yep, it would print Iron Man 3. It would not print Iron Man 3 2004, it would just print Iron Man 3. The reason is complicated, but basically the way that strtoc is able to get away with never needing to allocate new C strings is that as it tokenizes your original C string, it replaces the delimiters with null terminators, and then it just returns pointers that point to different parts of the original C string. And that's how it does the tokenization. It's a little silly. It's kind of a nasty interface. It's messed up programmers all over the world a million times. Brewster has a fun slide on it.
I guess it's efficient though.
It is efficient. It's memory efficient. And C was designed to be memory efficient. Here's Brewster's slides on it. It splits strings into chunks. It makes your hair fall out. It maxes out your credit cards. It unfriends all your social media friends. But sometimes it's the best or only tool for the job, right? It's a really weird interface, but it works if you know how to work with it. It is non-reentrant. It's not thread safe. There's strtoc R for that, but we're not going to talk about it. Yeah.
It's if the memory was dynamically allocated to the specific function because of the null terminator.
You would have to free it yourself still, but there isn't an issue with that. Null terminators don't play into freeing. Yeah. Yeah. Stir to L. Let me see. Maybe I'm wrong. Stir to L. Oh. Yeah, it is a little more complicated than I remember it being. This would be the C string. This, I think you just pass in null usually. And then, oh, that's right. So when you're calling stir to L, pass in your C string. The second argument, just pass in null. You can read the documentation to understand why. And then the base is 10 if you want it to be treated as a base 10 number, which you usually do. There is also another function that always does base 10. I don't remember what it's called. Stir to L10 or something like that. I think it's in my lecture notes. But either way, check out the lecture notes for stir to L and stir to D. Okay. We would take a break, but I want to get through dynamic memory and file access for assignment 1. So you're prepared to do assignment 1 this week. So is everybody okay with just pushing forward? Okay, we've got 30 more minutes. Let's do it. Okay, Dynamic memory. Does everybody in here, okay, show of hands. Who did not take CS261 in person at OSU? Okay, of you raising your hands, who did not take CS162 in person at OSU? Okay, of you raising your hands, who has never used new, delete, malloc, or free? Okay, so everybody, okay, one maybe. So pretty much everybody in here understands dynamic memory, malloc and free, or new and delete. So hopefully this is mostly just a syntax thing. If you don't know much about dynamic memory, I suggest reading the lecture notes, because I don't really have time to cover the fundamentals of dynamic memory. I'd rather just cover the syntax of dynamic memory. In CS162 and in CS261, we cover like the fundamentals of dynamic memory. So it's technically a prerequisite to this course. So let's treat this as just like a syntax problem rather than covering the fundamentals. So in C, suppose you want to dynamically allocate an array. In C++, you would use the new keyword. In C, the new keyword doesn't exist. In C, here's how we do it. Just like in C++, you use a special function, and it will return a pointer to the base address of a dynamically allocated chunk of memory. So I need to create a pointer in which to store that base address. Maybe I want to create an array of n doubles. Or maybe n is read from the user through scanf. Okay, and then I want to create an array of n doubles. Maybe for the purposes of like resizing, because dynamic arrays can sort of be resized in C. Here's how I would do that. I would say double pointer. This pointer will point to the beginning of a dynamically allocated array of n doubles. In just a minute, I'm going to call it array. Gets. Here's the weird syntax. You say malloc, stands for memory alloc. There's a little more to it than this, but we'll get to it. And then you pass in the number of bytes that you want to allocate. I don't want to allocate n bytes. I want to allocate an array of n doubles. Each one of those doubles is many, many bytes. Usually it's going to be 8, but either way, each one is more than 1 byte, right? So here's what you usually do. You take the size of a double. This is the size of operator. You give it a type or a value, and it tells you how big that thing is in terms of bytes. We would then multiply that by n. I want an array of n doubles. Each one is this many bytes large, and so that's in total how many bytes of memory I need to store all of these doubles, right? It will then allocate an array of that many bytes. What it returns is a very generic kind of pointer. It doesn't return a double pointer. It returns a generic kind of pointer known as a void pointer. You have to take that return value and convert it into a double pointer in order to store it in the double pointer on the left. We do this by casting. So in parentheses, we've seen casting once before. In parentheses, you write double pointer to convert it to a double pointer. This is how you do that, semicolon, okay? This is sort of the C equivalent to double star array gets new double n. This is how you do this in C++. This is how you do it in C. A lot more syntax, but that's how it works. Also, malloc is not like a built-in in C. You have to include a certain library to use it. Do I remember the header file? Malloc C, Linux Man 3. It's the standard lib header file. Include standardlib.h, or include another header file that includes standardlib.h. Okay? Okay. Now we can use malloc. Just as you can dynamically allocate memory with malloc, you can free dynamic memory with free. So free is sort of the C equivalent to C++'s delete. So you say free, and then in parentheses, you supply the pointer to the dynamic memory that you want to free, and it will free it. So this is equivalent to new, and this is equivalent to delete, if you've worked with C++ before. That's sort of your analogy, right? Okay.
So you free all the mallocs?
Yes. For every malloc, you should usually have a free, but there is an exception that I'll show you in a minute. Okay, there's something called realloc. Okay, so let's make sure this works. Main.c, we run it.
You just make an array. Would you have to free that array too?
Hold on, what's going on? %d, %n. Oops, no \n. Okay, GCC, A.out. If I say 25, it should allocate an array of size of 25 doubles, right? Okay, how do we know that this worked? Whenever you want to debug a program, honestly, any program that uses pointers, you should do what I'm about to show you. When you compile the program with GCC, add this little -G flag into your compilation, right? This will inject these little debugging symbols into your executable, which makes it easier to debug using certain tools, like one that I'm about to show you. So I called it main.c. I think that's what I called it. Yes, main.c. And then you can still give it a name if you want. I'm just going to let it be called A.out. Just make sure to supply that little -G flag. Okay, it works the same as before. I've got this program called A.out. But now, this program, A.out, has these special little debugging symbols inside it, which assist debuggers. There is a debugger on the OS1 server known as Valgrind. It's technically like part of this larger framework known as Valgrind with a capital V, but the shell command is Valgrind. You can run executables through Valgrind, just like this. So if you wanted to run A.out, you would just type /A.out. If you wanted to run it through Valgrind, you would say valgrind./A.out. That's VALGRIND, Valgrind.
I thought you didn't need the -G when compiling to use Valgrind though.
You should. You technically don't need it for certain things, but it will help you like locate, like track origins, like locate where leaked memory was allocated and things like that. So you generally should. So valgrind./A.out. If I do this, it will give me certain diagnostics about the memory of my program. It will tell me if I've leaked dynamic memory, for example, if I forgot to free it. If I run it, and then I give it the size of the array, 567, notice there was one allocation, that was one call to malloc, and one free, that was one call to free. 0 bytes and 0 blocks were leaked. That's good, no memory leaks. If you have memory leaks in your program 1, you'll probably be penalized for it. So make sure to use Valgrind to check for memory leaks. You can also use Valgrind to locate other kinds of memory-related errors. Invalid reads, invalid writes, invalid frees, uses of uninitialized values, basically almost any instance of undefined behavior, except sometimes like buffer overflows and overreads. If they occur while your program is running through Valgrind, it will print out a little message that tells you that the error occurred. And if you compiled your program with -G, it will even tell you on what line of code the error occurred. And so you, as you're working on program 1, you should always compile with -G. You should always run it through Valgrind and heed its error messages. And if there are any memory leaks, make sure to free those up. If there are memory leaks, you can ask Valgrind to tell you where that leaked memory was allocated. To do this, you do a couple things. Leak check equals full, and then show leak types equals all. Is that what it is? Anybody remember? It's in the lecture notes. I think it's this.
No, it's --leak check equals full.
Well, I already got that one. There's another one where you can tell Valgrind to show certain kinds of leaks that it normally would hide, for example, memory that's still available at exit. I don't remember what it is. Check the lecture notes. Show leak kinds. Show leak kinds. Oops. Show leak kinds equals all. So if you run Valgrind like this, it will give you more diagnostic information about your memory leaks. In my case, I don't have any memory leaks, so I don't really need it, but it's helpful. Okay. In theory, that's all you need to know about dynamic memory in C for assignment 1. There's one more thing I'll tell you, which is this thing called realloc. Realloc. Malloc is used to dynamically allocate an array of a certain number of bytes, and then or technically just a buffer of memory, and then it returns a pointer that points to it. And you could use it like an array. Realloc is used to reallocate an existing dynamic array. So suppose I already have a dynamic array, and I've got this pointer that points to it. I can reallocate array. You again supply the new size that you want it to have. So maybe it's currently of size n. I want to expand it to be of size n plus 1. So the size would be size of double times n plus 1, something like that. It will reallocate this array to make it 1 double bigger, like 8 bytes bigger in memory. It will then return a pointer that points to it. And if in the process it needed to actually create a new array in memory in order to support this expansion, which it often will, it will automatically free the old array and give you a pointer that points to the new one. So that's to say this program now allocates 2 arrays, and it frees 2 arrays. malloc allocates the first array. Realloc deletes the first array and allocates a new array. Free deletes the second array. Also, realloc, in the process of allocating this new bigger array and to expand the original array, it will, like byte for byte, it will copy the bytes from the original array to the new array. Like it just does this for you. And so you don't have to worry about like manually copying bytes over. Sometimes this won't need to actually allocate a new bigger array. It will be able to just expand the existing one. It depends on if there's space in memory for it to do that. But often it will allocate a new array. So this is just slightly more efficient and easier than allocating a new array bigger using malloc, copying the data over yourself, and so on. Yeah.
I have a question about SDR top. If the first character in the string is a delimiter, will the first result be
I think the first result would be an empty string, because it would replace that delimiter with a null terminator. And then you'd have a string that starts with a null terminator. Yeah. Good question. For assignment 1, you don't have to worry about that, because every column will have a value in it.
We have to parse the array, so we have to parse the gap.
The array of languages?
Yeah.
Yeah, you might have to deal with that. There are ways where you don't have to worry about it, though. Because the array of languages will always have at least one language in it still. There are ways of using strtoc where you supply a square bracket as one of the delimiters to catch the beginning of it. Oh, then the first one's going to be that. Yeah, there are other ways too, though. Yeah, there are other ways. Yeah, I could trim the first character. There are lots of ways. Okay. For assignment 1, you probably aren't going to use realloc, because for assignment 1, you're not creating dynamic arrays that you expand. You're creating a linked list that you're going to expand. In assignment 1, you're basically going to do this. You're going to read a line of text from the CSV file. You're going to create a movie structure. You're going to tokenize the line of text. You're going to take each token, and you're going to convert it to the appropriate type, maybe with stir to L, maybe with stir to D, maybe with A to I, something like that. You're going to store the converted result in the appropriate member of your movie structure. You're then going to create a new node for your linked list. The node is going to be on the heap. So you're going to create it with malloc. And it's not going to be size of node times n. It's just going to be size of node, because you're just creating one node on the heap. You're then going to add that node, well, basically add the movie structure into that node, and then you're going to add the node to your linked list. It's going to be something like that general process. But because you're creating one node at a time, you're going to allocate them one malloc at a time. Not times n, just size of node. And you're also never going to reallocate them. Just one node, one node, one node, link them all together. In the end, when you're ready to free them, you would free them all one at a time, like in a loop. You might need it for the title. There are ways of doing the title, though, where you don't really need it. You could just count the length of the title and then dynamically allocate a C string of that length. So you wouldn't need a realloc. Okay, let's do file access. Basics of file access. And then you'll be ready for assignment 1, to complete assignment 1.
I didn't mean to realloc. I actually needed malloc.
You'll still need to do malloc for the file. So yeah, in assignment 1, the movie titles can be of any length. You can't just assume that they're like going to be no more than 200 characters or something like that. They could be of any length. And so to support the length, an arbitrary length for your movie titles, you're probably going to need to dynamically allocate C strings to store those movie titles in. And the lengths of those C strings need to be big enough, at least, to store the corresponding movie title. So you're probably going to use strtoc to get the movie title out of the row's C string. And then you're going to use strlen to get its length. And then you're going to add 1 to that to make room for a null terminator. Then you're going to take that size, and you're going to create an array of characters that big to store the movie title as a C string. That's probably how I would do it. There may be other ways of doing it, but that's one way. Okay, let's do file access. Luckily, this will go pretty quick because file access is kind of easy. Okay, there are 2 general ways to do file access in C, like with the C standard library. One is by using these functions from fcontrol.h and unistd.h. It's like from the POSIX Unix standard, like read and write and open and close. And they operate on these things called file descriptors, and it's very complicated. We're going to talk about that on Thursday. There's an easier way of doing file IO in C, and that's using functions straight from standard IO.h. So the same header file that you're already including for printf and fgetS and getLine, it also offers functions that let you read and write to and from files, right? So there are, let's say there are 4 of them that we kind of need to talk about. There's fopen, there's fclose, there's fseek, but we're going to skip fseek because it doesn't really matter. There's, if you wanted to write to the file, there's fprintf, which works very similarly to printf. And then if you want to read data from a file, I've actually already taught you how to do this. There's fgetS and there's getLine. If you wanted to do something like scanf from a file rather than from the terminal, there's this thing called fscanf that you can use. Of all of these, the one that you'll use in assignment 1 is probably getLine. So that's the one that I'll show you. Okay, so the goal. We have a program. We want it to open a file. And we want it to read data from that file or write data to that file, right? As opposed to reading data from the terminal or writing data to the terminal, right? We have to start by opening the file. There's this function provided by studio.h called fopen that does this for us. It returns a value of type file star, where file is all caps. I don't know why it's all caps. I have absolutely no idea. This is a massive violation of the general naming conventions of the C Standard Library.
Like to name their variable file.
Yeah, because people like to name the variable file, so they make it all caps.
Examples are like that. Like,
Yeah, it's also weird because it's not like a structure, because I don't have to say struct file. It's just file pointer. I don't really know what it is. It might be a type def for something weird. I think it's just kind of like handled magically by the compiler, but I don't really know. This is its type, file pointer. It is a file stream, kind of like standard in. Standard in is of type file pointer. So that's how you can think of it. I'm going to call it, sure, file. That's a good idea, right? Equals fopen. Fopen takes 2 arguments. The first argument is a C string containing the path to the file that you want to open. Let's say I want to read data from a file called moviessample1.csv. Okay, remember, in assignment 1, you shouldn't hard code the file's name. You should read it as a command line argument through argc and argv. So maybe this would be argv at index 1 or something like that. But I'm going to hard code it for this demonstration. The second argument specifies what you'd like to do with the file. It's also a C string. If you want to just read from the file, just put an R in here. R stands for read. If you want to be able to write to the file, put a W. W stands for write, but it also does truncation. What does that mean?
after you write it cuts off the end.
If the file already exists, then this stream will allow me to rewrite the file, but specifically rewrite it from scratch. It will erase the existing contents of the file or truncate it, and then as I write into the stream, it will replace the contents of the file with whatever I write. Okay? If you wanted to append to the file rather than truncate, you pass an A. If you want to be able to read and write from to and from the stream, from one stream, you could do something like R+. That's read and write. There's also W+. That's read and write with, it doesn't truncate, but it's read and write, but it also will create the file if it doesn't exist. There's also A+, read and write append also creates the file if it doesn't exist. For simplicity's sake, we're probably mostly just going to use R and W in this class. R to read from a file. This is what you'll do on assignment 1. Read from the CSV file. Okay. If this succeeds, then file will not be null. If this fails, maybe because this file doesn't exist and I'm trying to read from it, then this pointer will be null. So you can use that to check if it succeeded. Although I don't think you technically have to check in assignment 1. You can assume that the file exists and that it will open. I think. Double check the rubric. Okay. Anytime you open a file, when you're done with it, you have to close the file. To do this, you use the fclose function. Is fopen or is fclose? Fclose just takes the file pointer, the file stream, and it closes it. Again, it returns values and it sets error numbers to tell you whether or not it succeeded. If you're paranoid and you want to check whether it succeeded to close the file, you can do that with if statements and such. Refer to the lecture notes. but you usually don't need to worry about it, especially for closing. Okay, suppose I want to read data from a file. I've opened it for reading, so we can read data from a file. When you first open a file, and this is true if you open it for reading or writing, when you first open a file, there's this little thing, it's technically called the file offset. You can basically imagine that there's a little cursor that points to a certain place in the file. And when you first open the file, that cursor, the file offset, points to the beginning of it. So for example, maybe there's movie sample 1.csv, and it's got Iron Man 3, 2004, something like that. When I first open this file with fopen, there's this little imaginary cursor that points to the I, the capital I, the very beginning of the file. When I start reading data from the file, anytime you read data from a file or write data to the file, it works from the location of the cursor. The cursor starts in the beginning. As you operate on the file, reading data or writing data, the cursor shifts. Cursor will move, right? So if I read an entire line of text from the file, let's say there's a second line of text, something like that. If I read an entire line of text from the file, the cursor will shift down to the next line. If I read, let's say, a single word from the file, it will shift over to the next word. So as I read from the file, this imaginary little cursor moves. That cursor is stored inside the file stream pointer, right? So what do I call it? Studio read. It's stored inside this variable, basically. So this variable constantly keeps track of sort of where it's at in the file. It starts at the beginning. So suppose I wanted to read the first line of text from the file. To read a line of text, you can use one of these two functions, fgetS and getLine. I've already shown you these functions. Previously, we used these functions to read from standard in. Now we're just going to use these functions to read from file. So we're just going to replace standard in with file. Both of these things are of the same type, file star. So you can they're just interchangeable, whichever one or whichever stream you want to read from. So here's what we do. Again, I'm going to create my character pointer that's going to point to the first line of text from the file. We'll call it first line, maybe first row, right? Something like that. Initially, it must be null. You must set it to null. Always with getLine, remember to set your character pointer initially to null. I create a size t value n. I'm going to set it to 0. This will store the size of the allocated character buffer to store the first row. Okay, and then I do getLine, same as before. For the first argument, I pass in the address of first row because we wanted to modify this pointer to change it to point to a character array, storing that first line of text. I pass in address of n because we want it to modify n to store the size of the character array that is allocated. And then for the third argument, previously I passed in stdin to read from standard input. Now I'm going to pass in file to read from the file. This will read the first line of text from the file. Suppose I then wanted to trim the line feed at the end, the enter character at the end of the line. One way of doing it, as I showed you before, is to basically grab first row, grab the C string, grab the last character, like the last actual text character in it, which is currently a line feed, and change it to a null terminator. So we can get its length with strlen, first row. We subtract 1 because indices start at 0, right? So if the length is 20, then the index of that line feed is 19, and then we replace it with a null terminator, something like that. That will trim the null terminator at the end. There's another way to do this. Somebody pointed out earlier, getLine also returns the length of the C string. Understand that n is not the length of the C string, it's the length of the character array that is allocated, which could be much bigger than the C string, but getLine does return the length of the C string. So I could also say size t length gets getLine. I think it's technically s size t, sign size t. But then I could just use length minus 1 rather than strlen, but it doesn't matter. If you don't want to have to remember that, just use strlen. Strlen will always work. Okay? Okay. If I want to print that line of text to the terminal, I can maybe printf \n or %s \n first row, something like that. That should read the first line of text from our CSV file and print it to the terminal. Let's make sure it works. Although I think I'll need to include string.h to get access to strlen. There it is, the first line of text from the file. Make sense? Okay. Suppose I then wanted to read the second line of text. How do I do that? Just call it again, right? So as I said, when you open the file, there's an imaginary cursor that keeps track of its current location in the file. It starts at the beginning. When you call getLine on your file the first time, it reads the first line of text, and it shifts the cursor down to the next line. So the next time I call getLine, it will read the second line of text. And the next time I call getLine, it will read the third line of text. So if I want to get the second line of text, I just have to do all of this stuff again, right? Create another character pointer, second row, change first to second. I can't call this n, but I can just reuse the existing n, I guess. Again, still reading from the same file stream, but this will now read the second line, and then maybe I want to print it. Copy paste. Print the second row. Second row. In your program, you're probably going to do this in a loop, and I'll show you how to detect the end of file. Okay, but it'll be something like this. There's the first row, here's the second row. Questions so far? Okay. Now suppose you wanted to do this in a loop, and you wanted to just keep reading lines of text until eventually you get to the end of the file, right? getLine can sort of detect the end of the file. It's capable of detecting end of file scenarios. When you get to the end of the file, getLine, well, I mean, one thing that you can do, it will always return the number of characters that were read and stored in a C string, including the line feed character. So when you get to the very end of the file and you try to read one more time, even though there's no more text to read, it will return 0 because there are no characters to read, so it doesn't need to actually read an actual C string. So number of characters that it reads will be 0. So one way of detecting the end of the file is just to check if this returned 0. That will usually work. Another thing you could do, and this is in the lecture notes, there is a special function called FEOF. I don't remember the exact interface. You give it a file stream though. Maybe I remember the interface. I think you give it a file stream and it basically returns true if you've reached the end of the file and false otherwise. And when I say true and false, I really mean a non-zero integer or a 0 integer, because that's how C represents trues and falses. Understand that both of these methods that I just told you, checking if getLine returns 0 and checking if FEOF file returns true, both of these methods will only work after you've made it to the end of the file and then tried to read one more line. After you read the last actual line in the file, this will still return false, and that last call to getLine will still not return 0. Only after you've read the last line in the file, and then you've attempted to read one more line, which doesn't exist, only then will this return 0, and will this start returning false. So that really matters for assignment 1 when you need to read lines from your CSV until you get to the end. It's that last getLine after you've read the last line of actual text. That's when you detect the EOF. And then you like break your loop or something like that. Okay, good. I could tell you about fprintf, but I don't think I really need to today because you don't need it for assignment 1. Is there any last advice I can give you for assignment 1?
I wanted to ask about assignment 1.
If you have personal questions, you can ask after lecture. Okay, questions or comments? All right, good luck getting started on assignment 1. I'll see you on Thursday.